This video is about current. It corresponds to section 4.2 of the Applied Analog Electronics textbook. Current is something that we associate with components in a circuit. So, if we have a component, nodes A and B, and we have charge flowing from A to B, that flow of charge is referred to as current. We'll usually abbreviate current with the capital letter I. And this would be current from A to B. I've drawn the arrow there to indicate that if I have a positive value for that, that's current flowing in this direction. Now, when I'm talking about positive current, we're talking about conventional current flow. And conventional current flow is with positive charge carriers. Now, in a lot of cases, we're going to be having electrons as our charge carriers. In metals, for instance, the wires that we use, the charge is going to be carried by electrons, and the electrons are going to be moving in the opposite direction from what positive charge carriers would have been moving. And so a movement of electrons from A to B would be a negative current because it's negative charges moving from A to B. There's a useful analogy for current, the hydraulic analogy. And that is to think of these components that we've got here as being like pipes. And current flowing through the component is like water flowing through a pipe. The way this works as an analogy is if we put two components in series, so we go from A to B and another one from B to C, the current flowing through this one, unless there's a leak somewhere, and I haven't drawn any places here for there to be a leak, there's nothing else connected, the current flowing in through one component has to flow through the other component as well. So those two currents have to be identical. Similarly, if we've got two components and we hook them up in parallel, say component 1 and component 2, then the current through component 1 and the current through component 2 are going to add together, and the total flow through this whole thing is I1 plus I2. And when I draw currents, I often like to draw them as an arrow to indicate which way positive is. So that if I put a positive value on I2, that means the current is flowing in that direction. It's also possible to do it with the subscript notation, but quite often we don't name all of our nodes, and so if this node isn't named, there's nothing to give subscript for. But I can still draw an arrow next to a component to say which way is the positive direction for current flow through this component. Incidentally, the hydraulic analogy that I'm giving here of pipes can also be applied for voltages. If we think about it in terms of voltages, remember we had VAB and VBC adding together to be VAC. And if you want a hydraulic analogy for that, think of the voltage as being like pressure. Pressure drop across A and B, a pressure drop from B to C. The total pressure drop is from A to C. And here, if I just have giving these things names, the pressure drop from A to B is the same no matter how many pipes there are in between. It's just the difference in pressure between those 2 points. So voltage corresponds to pressure, and current corresponds to flow. And those analogies sometimes help people in understanding what's going on in simple circuits, keeping what's voltage and what's current apart. It also explains why we talk about voltages across a component. It's the difference in voltage between the two components. It's not something that's going on inside the component. But we talk about current going through a component. So you never want to do voltage with through or current with across. It's voltage across and current through a component. And that's probably enough about current for now. In a subsequent video, we'll take a look at the relationship between voltage and current and look at Ohm's law.